to technology to have them do something to it?
No.
You're on the list. I'm on the list. And Maria's on the list.
So do I do that?
You don't do that right now, but sometime during your day when you have a free moment.
What's wrong with it?
I don't know. There's something you have to do to it. Okay, did you turn it on?
Yeah, I did. I turned it on.
Okay.
Oh, wait, that's on video. No. How's it going?
Okay, here we go. Here we go. Delaney, you said you remember how to do this?
I watch them in the video
Survive. I was getting in the line right.
Okay, so Delaney says, let's get cosine and sine by themselves. Now, keep in mind that the big picture here is when we're trying to eliminate the parameter, we often use substitution. So we get t by itself. Well, you're not really going to be able to get t by itself here, but you can get cosine t and sine t by themselves. Okay, then what, Delaney?
Square everything.
If we square everything, we'll have x squared over 9 equals cosine squared, and y squared over 16 equals sine squared. Now, those of you that were here yesterday, and those of you who weren't, who watched the video as you were supposed to have, now these start to look familiar. What's our objective here? What's going to happen? Remember Harry Payton? You were so excited yesterday.
Oh, yeah, it goes to 1.
It goes to 1. When you add these together, when you add the left sides together and the right sides together, the left sides are x squared over 9 plus y squared over 16, and the right sides are just 1, because sine squared plus cosine squared is 1. Now, any t's left in this equation? No, so you have removed the parameter, taking care of that part. Now, does anybody know, this is kind of an unfair question because we haven't studied it this year, but you certainly studied that last year. What shape is that?
Circle.
That's not a circle.
Oval.
It would be a
Octagon.
circle if these two numbers matched. Since those two numbers don't match, it is an ellipse.
Ellipse.
What's that yours?
Ellipse.
It is an ellipse. It is an ellipse. If these two numbers matched, then that would be the radius, and you would have a circle, but that's an ellipse. All right, any question about that? All right, how about this one? You remember how to do this one from yesterday? Delaney says, let's start by writing the vector equation of the line. So in other words, one big long line that represents, or one big long equation, I should say, that represents the line. Okay, so we have x, y here, okay, equal to what? What goes in this first parentheses?
Either point.
Either point, that's right, a point goes in that first parentheses. Either one, a point on the line. There are infinitely many of them, you've been given 2 of them, just pick one. Do not, Carter Hobecker.
Said there's a blue Chevy. You could not park in the C parking lot and you have your lights on.
Do not put the other point in there. That's not what goes in there. What goes in that last one, Carter Hobecker? Okay, who remembers the slope? We actually call it, because it's written as a vector, not a fraction, we call it the direction vector, but it's the same as the slope. In getting from this point to this point, how do you move? From -1 to 3 is 4, and from 2 to 6 is 4. That's the direction vector of the line. Somebody asked yesterday, and I don't remember if it was in this class or not, somebody said, instead of going from -1 to 3, can I go from 3 to -1? And the answer is absolutely. That would make this a -4, and then 6 to 2 would make that a -4. That's perfectly acceptable. It represents the same slope. Right? Up 4, right 4 is the same as down 4, left 4. That slope is the same. Now, we haven't answered the question though yet, because our job was to write the parametric equation. So what are the parametric equations? X equals,
Plus
well, let me go back to the original I had. So that would be plus 14, and then y would equal
2 plus 4.
2 plus 14. Now, this problem is a grading issue for me, because this is one answer, right? One set of answers. But did we have flexibility in the choice here? So this may not be -1 and 2. This might be 3 and 6. And this might not be plus 4. It might be -4. So there are different ways you can answer that question, and they would all be right. What did you say, Harry?
Oh, I was just saying that's crazy.
Isn't it?
Yeah.
Yep, totally crazy.
You don't have to be alert on that one. You can just throw stuff in there and it works.
That's right, no alerts on that one. Okay. Now, having done that, let's look at last night's homework, which was 6-3. Did anybody find something in the book that was confusing to you? Anybody? Remember, our quest is only over the first 3 sections of the chapter. So if anybody had any questions about this? Delaney? 41. Okay, so we're looking in our book at page 41. Parametric equations, x equals 2 cosine t, y equals 2 sine t. Hey, we just did this, and one like it, right? Now, they tell me in the problem what this is, but you guys, look, we already know what this is, because we've done a couple, one just a minute ago. When I square everything and add, I'm going to get x squared over 4 plus y squared over 4 equals 1. See how these two numbers match? We just talked about it. When those two numbers match, we have a circle. So it's a circle centered at the origin with a radius of 2. Now, they told me that in the problem, but you're going to have to be able to do this, so I thought we'd run through it one more time. Start with these parametric equations. Ultimately, that's going to generate this equation right here. A circle centered at the origin with a radius of 2. Okay, now what does it say? Okay, yesterday when we graphed this on our calculator, we graphed these equations on our calculator. Do you remember how we set it up? First we were in parametric mode because these are parametric equations. But then how did I have you set your window? We put it in radian mode. And we went from 0 to 2 pi. And the reason we went from 0 to 2 pi is so that we would go all the way around the figure, right? Whatever it was. In this case, it's a circle, but whatever shape you had, we want to go all the way around the circle. We talked about if we were in degrees, we wouldn't go 0 to 2 pi. We would go 0 to 360, right? To get all the way around. Now, the question says, it's actually a pretty easy question. It says if we only wanted to graph, this is a circle centered at the origin with a radius of 2. If we only wanted to graph the first quadrant, what would we tell our calculator if we only wanted the first quadrant? Instead of going from 0 to 2 pi, which gives you the whole circle, go only from 0 to pi over 2. And that would graph only this right here. If you don't believe me, try it. Put in these parametric equations and tell t, min to be 0, max to be pi over 2, and you're only going to get this part. Well, what if you wanted the part above the x-axis? What if you only wanted to graph this part right here? 0 to pi. What if you only wanted to graph the part to the left of the x-axis, or the y-axis, I mean this part right here? What would you tell it if you wanted that part? Pi over 2 to 3 pi over 2. you are in control of what gets graphed when you set your window. When you tell your calculator what t values to sketch, you're telling it where you want to see the picture. 0 to 2 pi is all the way around. Okay? All right. Anything else from this page? Yeah, Maren.
Number 13.
13. Eliminate and identify. Okay, well, we kind of did this, but I see what the tricky part of this question is. There's a little added piece in there that we haven't talked about, so let's look at that.
That's what I was about to say.
Maren, did you have an idea how to eliminate the parameter? That part of it?
I substituted x for t. Like I gave t equal x basically, and it's
You gotta be careful. We're gonna get, that's fine. We gotta get t by itself, but t won't equal x. Let's see, if we take this equation and solve it for t, we'll have x plus 3 over 2. Does that make sense to you? Now that, I can plug into here if I want. What I like to do with all these hideous fractions, I like to do the same thing with this equation. So this is my personal choice. Certainly, at this moment, you can take this and plug it in here, if that's what you want. I like to go ahead and solve this one, y minus 9 over negative 4 equals t. And then I set them equal to each other, and I don't know, for some reason, that's just easier for me. X plus 3 over 2 equals y minus 9 over negative 4. And then I can cross multiply, and I don't have to worry about all the common denominator crap that I was gonna have to deal with up here. So negative 4x minus 12 equals 2y minus 18. I'll just cross multiply. So negative 4x minus 2y equals negative 6. I can divide by negative 2. So 2x plus y equals 3. Or y equals negative 2x plus 3. Either one of these is okay. It just depends what your personal preference is. Now, you have eliminated the parameter. This is what shape? What is this? It's not a circle. That's a line. You get a line. Here's the tricky part, though, because they told you that t had to be between 3 and 5. Now, does anybody have an idea what that's going to do to the picture? If you say t has to be between 3 and 5, do you have any idea what that means in terms of the picture? Exactly. It's kind of like this, only it's not circular. This is a line, but when you are giving it a beginning and an end, you're saying, okay, I can't have the whole line. I have just this segment of it. So what would be the end points of that segment? Well, if you let t be 3, that end point, if t is 3, would be, let's see, if you put 3 in here, you actually get 3. And if you put 3 in here, you get negative 3. So this segment goes from that point to the point where t is 5, which would be 7, negative 11. So what you have is this line, but only the part of it from this point to this point. That's good.
Oh.
Chill, first off. Second off, whatever you do, don't touch this tissue box.
You okay, Katie?
Yep.
Okay. All right, let's look at 3 plus 1. Oh, actually, let's not. Let's look at, in the packet, there's an old quiz we haven't done, so let's do that. It's called First Vector Quiz. And then we're gonna go to the back side of that paper, which is some in-class review problems to prepare us for our quest. Hey, do we have volunteers maybe to do problems 1, 2, 3, 4, 5?
Yes.
Good. They don't take up much room, so let's just come up, we can squeeze them all on this board. 1, 2, 3, 4. And maybe somebody would try the bonus also?
Yeah, I don't know how piece of paper or any identity is, but.
Who, are you guys volunteering?
Yeah.
Awesome.
We know, do
Yeah, you know.
I need the packet?
Oh, we need a packet.
Okay. Ben, I got it.
Yeah, you guys don't have to do all of these. Let's
Oh,
have some
we'll
more
do
volunteers.
all of them if you want.
It's actually good stuff.
We'll see what we can do.
All right, get through them.
We'll
Hurry
do
up.
all these. Yeah,
Hurry up.
so it's like, that's A. Wait, should have got more? Oh, I thought that was one. Maybe I'll look at them too.
Oh, you do the same thing, but you like multiply you by 2.
Like, move in.
No tiara.
So V plus this, so I just add them.
Did you do 2 even? Yeah.
Because like we didn't like just say that. She was like, I forgot. So I was like, it's okay, whatever. She read it was I was like, I don't care. So we're just like,
Anybody have a permission slip for the auction for me?
I have a question about that.
Yeah, let's lock that in.
6 is fine.
Negative U.
For the girls, because you're being asked already. Yeah, at the library.
Oh, I
With the
what
teachers
is that?
room.
Yeah, we like square that and square that, so it's like.
Are you sure?
It's like. Miss Forge.
What does that mean if it's in the absent? If it's in the absent?
Uh-oh. They can't remember what the absolute value notation means. Magnitude. How
Oh,
to define
distance.
magnitude, it's distance,
Oh, it's
Pythagorean theorem, square
so
law.
whatever I told you.
Okay, so
That'd be 4.
4 plus 9 is 13. With that bonus, find the 8 strings.
Okay.
I thought strings.
I want to watch that.
I thought you go to
We gotta get this.
It's like, it's 2 these are, and then these are actual multipliers, and these are vectors. Now, sometimes this tells me it's a vector. This is just like adding to the course code, that this is different than this.
Okay.
It's not a big deal, so don't sweat it.
Okay.
That's 86.
They have my paper, so I can't check. Are you guys okay with this one?
Yeah.
Yep.
Where's we got?
How about this one?
Yeah.
Number 2's okay?
Yep.
How about number 3?
Have to be.
Uh-oh.
One number. Yeah, they add them together.
Okay, so we got some confusion about number 3. When I get my paper back, we'll check that one. How about 4? Where are we on 4?
Yeah.
That's 5,
It's good.
and they're still working on the bonus.
Oh.
So everything but maybe number 3 is right. We're not sure about number 3 yet. We're gonna double check it.
Call it that. 10. Because you go. I'll get really okay. Hold on. 10 second break. Just count sticks or something like that. Okay.
So let's get back.
So after that is
We need to get to 6, don't we?
this would be 10. So it's like here's 8.
Oh, yeah. There you go.
So your answer is 8-6?
No, that's
Yeah.
Okay, let's take a look at, did anybody get 11-10 for the bonus? Did you not?
I got it set up, but I couldn't.
Okay, all right, so we'll talk about that one too. So, unless unless somebody says something right now, we are not talking about anything but 3 in the bonus. If you want to talk about one of the other ones, now's your chance. Read order.
Oh, boo.
4 is the opposite of vector u. So if vector u has coordinates 5, 1, the opposite would just be -5, -1.
Can't read.
Okay, now number 3. Number 3 is v dot u. Kids, v dot u is a number. This can't possibly be right.
Okay.
Because the dot product is a number. Now, how do we get that number?
tricked, baby.
We take -2 times 5, and we add 3 times 1. So they've got the right 2 numbers here, they just didn't add them. So the answer should be -7. Okay, guys? Got that? You okay with that?
Yeah.
I'm not okay with it, but
I accept it.
oh, you multiply and add them up.
Yep.
This is for
X times X, Y times Y, add them together.
This is for
What?
over 2.
Now, right now, I'm doing the bonus.
That's all.
Now, let's look at the bonus. First thing we had to do was find the coordinates of AC. So that's probably up here somewhere, I don't know. AC would have what coordinates? Is that here? 4, 3?
A to C, yeah, A to C is 4, 3. And then with a little 2,
A
then you
to
times it by 2.
C is 4, 3. That's exactly
And then you
right.
times it by 2.
Then we have to double it, so that would be 8, 6.
Yeah.
So we have a vector whose coordinates are 8, 6. That vector has to be the same as one that starts at B and stops at D. So in other words, this new vector has to travel 8, 6, over 8, up 6. And it has to start at the point 3, 4, because that's what the problem says. So if you have to start at the point 3, 4, and you have to travel over 8, up 6, where will you end? 11, 10. That's not a hard question. If you start here and go over 8 and up 6, well, 3 plus 8 and 4 plus 6. So that is exactly right. 11, 10 is the correct answer. Number 2 says take the coordinates of vector V and add double U. 2 U's. Katie, what's confusing you about that? 2 U's is 10, 2. You just said -2 and 10, and 3 and 2.
Gotcha.
All right, let's turn the page over. We got a bunch of review problems here. Now, I need you to keep track of which ones we're doing. Read down through that list. If somebody said to you, you have to do all of these problems right now, which ones would you struggle with?
None. I'd do them all so quick, they'd be so impressed. Which one?
Who sees one that you might struggle with? 6?
What's it asking? Yeah.
6 says find a vector orthogonal to vector V.
Okay, so. No, 6 is the exact same thing.
So here's vector V, and I want a vector orthogonal to this. Okay, what does orthogonal mean? It means perpendicular. And that would mean the slope has to be the opposite reciprocal. All right, so what's the slope of this one? It goes left 2, up 7, so what would its slope be? Negative 7/2, right?
Yeah.
So the slope you need is 2 7s, right? That means you're going up 2 and right 7.
Yeah.
So you need a vector that goes up 2 and right 7. So wouldn't that be this one?
Yeah.
Doesn't this one go right 7 and up 2?
Yeah.
Now notice what happens when we do the dot product here of these two vectors. X times x, y times y, add them up, what happens? You get 0, and remember we talked about that. If they are orthogonal, their dot product will be 0. By the way, there are tons of different answers that you could put here. That's the easiest one, but there are tons of them. Again, lots of answers, possible answers. Okay, anybody see another one? 5. Same question, same vector, I mean, except now we're finding a parallel vector. What does parallel mean?
Same slope.
Same slope. So you have lots of options. Left 2, up 7. What would be the same as that? What's another vector that has the same slope? Could we go left 4, up 14? Would that be the same slope?
Maybe. Yeah.
Yeah, that would be 14 over negative 4, which reduces to negative 7/2. How about positive 2, negative 7? Would that be another parallel vector? What's the slope of that one? Negative 7/2, same thing. How many vectors are there that are parallel to that one?
A lot.
A lot. Yeah, let's leave it at that, a lot. There are 2 of them. Maggie? 11. This was on yesterday's quiz.
There are too many feet touching. Let's cover that.
Okay, 11 says that we have this triangle out here.
Backed up, she'll just stop.
And we want to find the measure of angle B.
No.
Okay. Ben?
Yep.
Turn around. How do we find the measure of angle B? Got to find the vectors. What vectors?
BA, BC.
BA and BC. Very good. Yesterday we had some people find the wrong vectors. You can do the area with the wrong vectors, but you cannot find angle B with the wrong vectors. You've got to have the right vectors. So BA, 3 to 1. Negative 4 to 2. BC, 3 to negative 1. Negative 4. Negative 4 to 1. 5. So there are your 2 vectors. Okay, step 1 complete. Now what? Remember, we're looking for angle B. So what do we do now? Dot product. Dot product says multiply x's, multiply y's, add them together. What does that give me? What's that give me?
38.
38, perfect. Now what do I do with that 38? I set it equal to the magnitude of the first vector, that's BA. The magnitude of BA would be root 40, right? Not simplifying it is not the answer, might as well just leave it root 40. And BC, what's its magnitude? BC, 41, root 41. times the cosine of the angle between them, which is B. Dot product equals magnitude times magnitude times cosine. So 38 over the square root of 40 times 41 equals cosine B. So we can go to our calculators and we can second cosine that and tell me what you get for your for your angle.
20.22.
20.22?
Unless I typed
You have
it
to
wrong.
change. It's in parameters.
You don't need to, at this point, you're not graphing, so you don't need to change anything except that's a degree measure. So apparently he was in degrees. But it can be in parametric mode. The only impact that's going to have is when you graph. As long as you're not graphing, that won't matter. Okay, so then I want the area of the triangle. I was tickled at the number of people on the quiz who actually used the determinant to find the area. You didn't have to do this. This was an extra piece of information that I gave you. But you can always find your area by taking your two vectors and evaluating that determinant. So this determinant would be negative 10 minus negative 24. And I have to cut that in half. So what is that, 7? Now, just for fun, let's do area the old way, which is 1/2 side times sine of included angle. It better come out to be 7. You have the angle already there. 1/2 side, sine. Did that turn out to be 7?
So you just cross multiply those.
You got what?
Oh, never mind.
One way or the other, you have to be able to get the area.
Did you do 1/2?
Yeah, we do have families, I believe. Yep, it's 7. It's 7. Okay, time maybe to do one more. Keep track of which ones we've done, because we'll come back to this sheet tomorrow. What else do you see on here that you think maybe you wouldn't be able to do? 8. Find the work done. Okay, work. The basic format we start with is very much like the dot product. Work is going to be force times distance times cosine of angle between. So what's our force? Our force is 12. What's our distance? 10. Come on, guys, read the problem. It says 0, 0 to 10, 0. That's 10. That's a distance of 10. And the cosine of the angle now. The object is being moved this way, horizontally. It says 0, 0 to 10, 0. It's being moved this way. The force is acting at an angle of over 1 up 3. This is the angle in between. How are we going to find that angle?
Oh, we can do tangent.
I would. The angle is second tangent 3. And once I know that angle, that goes right here. So then I simply take the cosine of that angle times 12 times 10, and that would give me the answer. you need the direction of the force to find the angle. Homework for tomorrow is actually the next sheet in the packet, which is Prequest. It doesn't say number 1, but the other one says number 2. So this is the one that just says Prequest. 21 problems. But they're short. They won't take very long. Okay?
I only have the homework I was due yesterday.
Put it in place. Thank you. Permission slips. Please get me your permission slip if you're working at the auction. If you already turned it into Mrs. Myers, that's fine.
What do you need?
Yes.
Good?
Well, she should email me the permission slip, but I'll get it.